This is Algebra 1, Lesson 6.4. We're going to graph inequalities. So we all know how to graph a line in slope-intercept form. That's the y equals mx plus b. And we're used to having an equal sign. So we're going to do the same thing, but now we're going to graph an inequality, which has a less than, greater than, less than or equal to, or greater than or equal to sign. So the first thing we're going to do is just go ahead and graph the line. Okay, so we know how to do this. We go to the B, the y-intercept right here, and we put a point on the y-axis. We go to +3, put a point, and then we use the m, the slope, which is in front of the x. There's nothing here, so we know that means there's a 1. When it's a whole number, we know it's over 1. So this is telling us to go up 1 and then over 1. They're both positive. So we go up 1, over 1, up 1, over 1, and we sketch in the line. Okay, so we know that the points are on the line. The solution to this equation are just the points that are on the line. But when we have an inequality, we have more than just the line. So the first thing you want to do is graph the line, just like we're used to. It's called a boundary line. And then if there is a bar underneath, if it's less than or equal to or greater than or equal to, it means the points that are on the line are also included as a solution. If it's not an equal to sign, if it's a less than or a greater than sign, what we want to do is we want to dash the line. That means the points that fall on the line are not a solution to our inequality. They're not included. Okay, once we draw our line, our boundary line, if we're using a greater than symbol or greater than or equal to, we want to shade above. That means all the points that are greater than that line are on our solution. If we use a less than or a less than or equal to sign, then we're going to shade below. That means all the points that fall below that line are our solution. So let's go ahead and practice. So we have it in slope-intercept form. We know we start with our B, our y-intercept. Here's our y-axis, so we go to +1 and put a point. Now we're going to use our slope, our m. It's a +2, and we know if there's nothing on the denominator is 1. So from our point, we're going to rise 2, run 1. We'll do that a couple times. Rise 2, run 1, rise 2, run 1. And because it's just a less than symbol, we want our line to be dashed. That means the points that fall on the line are not a solution. If we would substitute them in, we would see that the inequality is not true. So let's go ahead and dash this line as best we can. Okay. Now we have a less than symbol, and we said if it's a less than symbol, that means all the points that are below the line are solutions for our inequality. And just for fun, let's practice. So I say that 0, 0 is a solution for this inequality. Let's see if that's true. I just randomly chose a point in our shaded region. So y is 0, and x is also 0. And let's see if it's a true statement. Is 0 less than 1? Sure it is, so it's in our solution. Let's choose a point that's on the line, and you should see it's not a solution because it's dashed. So I'm going to go ahead and choose our y-intercept. So from the origin, it's over 0, up 1, over 0, up 1. Again, this is a point on our line. It should not be a solution. Let's see if it works. So in place of y, I'm putting a 1. Is less than or equal to 2. In place of x, I'm putting a 0. Plus 1. Is 1 less than 1? No, that's not true, and that's why the line's dashed. Let's practice another one. Okay, here we go. We're going to graph the line. We started our y-intercept, which is +2. We're going to use our slope, which is -3. So we know if it's a whole number, it's a denominator of 1. So it's -3, so we're going to go down 3, 1, 2, 3, over 1, down 3, 1, 2, 3, over 1, down 3, over 1. This time there's a bar under it's greater than or equal to. That means the points on the line are included in our solution. So we're going to go ahead and make that a solid line. That's supposed to be a straight line. All right, and this time it's greater than. So that means we want to shade above our line. And again, just for fun, let's choose a point and make sure it works. So I'm just going to choose the point, how about over 2 up 0 right here. Over 2 up 0. We're going to substitute it in. In place of y, I'm putting a 0. In place of x, I'm putting a 2. And this should work because it's in our solution, our shaded region. So 0 is greater than equal to -6 plus 2. Is 0 greater than or equal to -4? Sure it is. It works. All right, here we go again. We're going to start at +4 on our y-axis, our y-intercept, and our slope is -1 over 2, so it's our choice where we want to put that negative. Do we want to put it in the top or the bottom? It's up to you. I usually do whichever one's going to fit on my graph. I think I'm going to go down 1 over 2. I'm going to use this one, down 1 over 2, down 1 over 2. There's a bar. That means our line is solid. That means the points on the line are our solution. And this one's greater than, so that means we shade above. Okay. How about the oddball circumstances? What if we have a graph that looks something like x is less than or equal to 2? You know, if you have a graph like this, you go on the x-axis, you find +2, and you draw a vertical line. Whoops. Okay. The problem is it's less than, so what does that mean? Which way do I shade? So what you want to do is just randomly choose a point and see if that's a solution. If it's a solution, you shade on that side. If it's not a solution, you shade on the other side. 0, 0 looks like an easy one to choose, so I'm just going to choose 0, 0. In place of x, I'm putting 0. Is 0 less than or equal to 2? Sure it is, so we're going to shade in that direction. And how about y is greater than 4? So we go on the y-axis, we find +4, and we know this is a horizontal line. Whoops, this should be a dashed line. Let me fix that. Okay. And it's greater than, so we know we're shading above. Please try the practice problems. Let me know if you have any questions. Thank you.